In the following, we will continue to discuss the delay loss throughput in networks. So before we start, let me make sure. Can you hear me? Okay. And also, can you see the share screen on Teams? All right. So this Wednesday, we already know the transmission delay. All right, at least transmission delay only. And we can continue. We have the others. Wait a moment. Here we have a loss. And in fact, previously I didn't know loss, but this one loss packet in router buffers. So exceed the output link capacity, and then it will be dropped. All right, so this is the loss. As for the other types of delay, we have these. Transmission delay, previously we didn't know already. So here, from the actually moving from the buffer to the transmission line. Well, the time required, it is called the transmission delay. And next one, before it can be transmitted, it needs to wait in queue. So we have a queuing delay. Well, in fact, we have the others. If we have free or available buffers, of course, the packet won't be dropped. All right. However, if we don't have free buffers, and then the packet will be dropped. All right. So this one, we have loss. And only the transmission delay and the queuing delay. No, we still have the others. We have nodal processing delay. And we have propagation delay. Propagation delay is somehow like you need to start to run from the source node to the destination node. Here, just the router, the current router to the next router. Well, we have the extra two delays, nodal processing delay and propagation delay. Well, if we have these, then transmission delay, queuing delay, and processing delay and propagation delay. All the delays actually the packet incurred sequentially. Because of incur sequentially, so we need to put them together. So we use sum. All right, so we have 4 types, and the delay will be incurred sequentially. Therefore, we have the sum. Well, if we have the sum and think about the previous calculation delay, why we just have the transmission delay? In the previous calculation, know that we have the assumption. We assume no queuing delay, and in fact, no processing delay, and also no propagation delay. All right, so because of 0 processing delay, 0 queuing delay, and 0 propagation delay, so we simply consider transmission delay. Well, is it correct? Of course, under the assumption, it is correct. But if you want to consider the practical scenario, we need to consider the other 3 types of delays. Well, if we have these, let us consider the scale. The scale of the 4 types of delay. Well, processing delay. What kind of tasks need to be performed by the router? Check bit errors. All right, and also determine which output link, and so that you can put the packet to the proper output link. Well, talking about the scale, that says how long regarding the nodal processing delay. It says it's really fast, so lower than a millisecond. Right, so this is the nodal processing delay. And how about queuing delay? Queuing delay is the time waiting at the output link. Waiting at the output link here, right? Waiting at the output link. Why? Waiting for transmission, for being transmitted. So waiting for transmission. If we have this waiting for transmission, you can consider. Think about if you wait in queue for a lunch buses. So what is the scale of the time? Perhaps a few minutes. All right, so at this is longer than a millisecond. So depends on congestion level. Well, congestion level, waiting in queue. If no one waiting queue, so you can get it immediately. So if we have that case, what is queuing delay? 0. However, sometimes you are not so fortunately, so you need to wait in queue, and wait in queue then it takes time. So queuing delay, normally it is the major factor of delay. So let me emphasize, this is a major factor. All right, so talking about delay, in fact, this is a major factor. And previously we have a transmission delay. Transmission delay, you need to follow the formula here, L over R. And in fact, if we consider some example, the transmission delay, it is not so large enough. So normally it should be a factor to consider. But compared to the queuing delay, perhaps this one, it is not the major factor. But at least we will consider. So that's why previously we consider transmission delay simply. Well, propagation delay, same. It is not a major factor, but at least we can have the calculation. What kind of calculation? If we know the right now we consider its wave, right? Wave propagation speed. If we consider wave, what kind of wave? Electromagnetic wave. So we have a wave, and wave normally we have speed this one. Or here we have this old, actually this one, the same order, but we change 3 to 2. Why? Because it is not the free space. So of course, the speed, it is somehow lower than the original light speed. Well, at least it is the current speed lower than light speed. If lower than light speed considered, how about the distance is 100 meters, and over the current speed, actually it's quite small. So this one, actually, we can ignore directly if we have the current speed around light speed. Well, we have the 4 type if we don't know the scale. So finally, this one, it should be the major factor. And then we can consider transmission, because you need to consider some effects of transmission. So at least you will consider transmission. As for processing or propagation, sometimes we may ignore. All right, but if you want to consider all the types of delay, we have the current 4 types. Well, if you want to have some actual example to look at the possible delay, you can check the applet here, and you can have the animation, right? So it says you can have interactive animation. For this one, I think I drop it. You can refer to the applet to have the the possible actions talking about the current 4 types of delay using the Java applet to have the operations. All right. Here we have the 4, but well, we have the similar calculation. L over R is the ratio, and D over S is the ratio. Well, even we have the ratio, here we emphasize transmission delay, propagation delay, and these. They are not the same, so they are very different here. The authors want to let you know they are very different. Why? Transmission delay is the time you need to put the packet from the output link to the transmission line, right? Put it, so how long you need to try to move it from the output link to the transmission link. This is the time, and the time we use away what is the length of the packet, and you have the capacity. So using the ratio, you will find this. Something like you have some operation try to evacuate, something like evacuate the current packet, and how to have the time. As for evacuate, that says you have some capability. Here the capability is transmission capability R. All right, so I may let you know by allow the packet being moved from the output link to the transmission line. Or maybe you can think about this is an evacuation, and so that you can get it to the transmission line. Well, this is the transmission delay. As for the propagation delay, it is moving behavior. Moving behavior says that you know something like the packet can run, and the running speed at the current propagation speed. Here we have the speed near light speed, and you need to find the distance. So the moving behavior, I think you understand clearly. So we have the formula D over S. All right, so they have the same way to have the ratio, but they don't have the same meaning because of different meaning. So they are the same. Of course, they are very different. All right, so we need to emphasize they are not the same.